In this video, we're going to be going through another interview question. Uh, let me just point out that this is actually very similar to what we have in lead code, question number 957. 957. So either I've seen it in multiple, like with different prog- uh, problem descriptions. It could be like that there are 8 houses active or inactive, and like surrounded by, basically represented by zeros and ones, and like if both sides or both the neighbors of the houses are active or inactive, the house is gonna become inactive, which means zero. Otherwise, if one side is active, then the house will become active, which is one. We're gonna be taking the other problem description, which is in the lead code. So, which goes like there are 8 prison cells in a row, and each cell is either occupied or vacant. And just taking the example from the lead code, that initially the prison cells are like this. We have 0, 1, 0, 1, 1, 0, 0, and 7. Oops, and 1. 7 is not a possible. Uh, it can't be in there because 0 means that there is the prison cell is vacant, and 1 means that the prison cell is occupied. Okay, so the rules are if a cell has two adjacent neighbors that are both occupied or both vacant, the cell will become occupied. So if we have, in this scenario, this is the only case where both of them are occupied, so this is gonna become 1. Okay, so this is gonna be their day, and also they're gonna be giving you the number of days. This is day 0. So on day 1, what's gonna happen is like this never changes uh, the status. Reason being, it has only one neighbor. So this is always gonna be 0. Am I true? No, no. It can change the status because we're gonna be considering the other one as vacant. Like on the leftmost side, we're gonna be considering this as vacant and this as vacant. Okay, so this has one active neighbor, which is gonna stay, it's gonna become 0. This has 2 vacant, so this is gonna stay 1. This also has 2 occupied um, neighbors, so this is gonna become 1. This has 1 occupied neighbor, this is gonna become 0. This has 1 occupied neighbor, this is gonna become 0. This has 1, and this has 1, and this is gonna, and this has uh, this has, how many neighbors does this have? This has 0, right? So if the cell, if a cell has 2 adjacent neighbors that are both occupied or both vacant, then the cell becomes occupied. Otherwise, it becomes vacant. So in the example in the lead code, they made it 0. Yeah. So basically we don't think them as both vacant, because if I ask you how many neighbors are active or how many neighbors are inactive, so the answer to this one is that only one neighbor is vacant. So it's gonna become zero. That's the reason it is becoming zero here. So basically my understanding is that they are always gonna be this first neighbor and the first person and the last person are always gonna have like one, because uh, regardless of the status of this one or this one, because they're gonna be only one vacant and uh, one occupied, either the one vacant or occupied, right? In either way they're gonna become zeros, so they are always zeros, I guess. Yeah. So day two, we're gonna go up to day seven. So day two, one is occupied. Over here, it is one is occupied. This one is occupied. This one is occupied. Both are vacant, so it's gonna become one. Both are vacant, it's gonna become one. Both are vacant, it's gonna become one, and this will always stay zero. Okay, day three. Again, one, it is always gonna stay zero because regardless of the status of this one, this cannot change. This one is gonna become one. This one is gonna become one. This one is gonna become zero. This one is gonna become zero. This one is gonna become, because two of them are occupied, it's gonna become, if the two are occupied, right, it stays occupied. Yes, it stays occupied, and then this is becoming zero because of only one occupied neighbor. This is always gonna stay zero. Almost there. Day 4, again 0, 0, 0, 0, 0, 1, 0, sorry about that, and 0. Am I right? Yes. Day 5 is 0, 1, because both of them are vacant. 1, 1, 0, 1, 0. This 0 is gonna become 0 and 0. Good. Sixth one is 0, 0, 1, 0, 1, 1, 0, 0. Is 6 right? Yes. And the last one is the seventh one, which is gonna be 0, 0, 1, 1, 0, 0, 0, 0. Okay, so now we understand the problem statement, right? Again, in the solution for this one, basically it's not that uh, like we won't be doing anything uh, fancy here. And why do I have that at the end? Nice. I think I added the pages before that. So we're going to be taking the current array, send it to a helper function, and the helper function, based on the statuses of that, it's going to be looking for, again starting from here, because this is always going to turn 0, right? So and the first and the last neighbor. So starting from here up to this point, we're gonna be looking for the neighbors, and then just sending returning another array. One thing which we wanna do, which is actually gonna save us a lot, which is gonna make the solution much more robust, is that uh, once we have the new one, so basically every single time we're gonna be converting this array of integers to a string, and we're gonna be putting that string into a set. So what would happen is, like, because you can end up having a cycle. So if you actually have seen a very similar condition before, right? Uh, so basically this string is gonna be equal to 0, 1, 1, 0, 0, 0, 0, 0. So basically we're gonna say that this is a string now, and this is, if you see it again, just say that okay, this has a cycle in it, and it's gonna keep repeating it. So the next one is 0, 0, 0, 0, 1, 1, 1, and then 0. So that's another thing we want to do. Okay, and once we do that, uh, yeah, so basically if we look at our set and then we see that okay, we have already processed it, that just means that uh, we'll be able to, we don't we can actually say that okay, it has a cycle in it, and based on that we can actually uh, take the modulus, and let's say if the cycle is at 5, and the n is, in our case, n is equal to 7, and the cycle is at 5, so you can just make n equals to n modulus 5 equals like that. So basically n is gonna, we only have to process twice after that cycle. Okay. uh okay, now I'm just gonna copy paste the code and then we can go through it. Nothing very fancy here. Let's just start from here. Okay, so basically we have the prison after n days. Again, we are doing the sanity check over here. uh, if the cell are null, or this is not the length, or like if there is no element in the cells array, and the n is less than or equal to 0, we're going to be returning that. We're going to be checking for the cycles, if we have found any cycles or not. Initially the condition, initially the status is false. Cycles is 0, like how many cycles, like how many of them, like basically how many. So in the example we said it's n is equal to, let's say, 7, and the cycles exist at 5, right? So if that is going on or not. uh, okay, the cycles is starting at 0, and we have a set. As I said, we're going to be converting the array of integers into the string, and we're going to be putting them in the set, and just to see that if we have the cyclic uh, redundancies in our iterations. We're going to be going through, I is going to be going through 0 to n, and now we're going to be calling this next day function, and next is like from one condition to another condition. We'll be going through this function in a second. Then once we get the next day uh, new cell statuses, we're gonna be converting them to a string and putting them, basically making it a string. We're calling it as key, and if the set contains that key, if the set does not contain that key, we're gonna add it and then add the cycle. Otherwise, we're gonna say that okay, we have the cycle, and we're gonna break out of this for loop. Because if we have found the cycle, that means like we don't have to, uh, basically if we have found the cycle, we, instead of going through again and again, we're gonna take the modulus, and then we're gonna just iterate that many times in order to get to the next cells. Okay, if Okay, if otherwise, if you have seen it in the set the hash cycle to true and then break. Otherwise, if that is not the case, everything whether this or that, like if you will come here, we're just breaking the loop. But if you just added it to the set, we're gonna say that the cells is equal to the next cells. So basically, we are going from day 0 to day 1, and then we're gonna process it again. If you have seen a cycle, all you have to do is to update, as I said, 7 modulus equals to 5. If we have found the cycle in that, so basically n is going to become equal to 2. We only have to go from 0 to 2 and just do 2 iterations in order to get the new uh, cells, and we're going to be returning cells in the end. Next day, the way it works is like you just make a copy of that into a temp, right? And then looking at the statuses uh, from basically we're starting from I equals to 1 and cells dot length minus 1. As I said, we don't want to process the first neighbor and the last neighbor. So again, the temp of I is gonna be equal to the cell we're looking at. The basically we're checking that if we are in the middle, right, we're not going to be processing this one. And if we are at this z, all we have to check if x is equal to y or not. If they are equal, the answer is this. If they are equal, whether zeros, both of them are zeros, or both of them are ones, right? This z is gonna become 1. Otherwise, if they are not equal, that's gonna become 0. And then we're gonna be returning the temp, like the processed array of integers. In terms of time complexity, because we have been given that the total number of cells are 8, or if we are taking the example of homes, we have been given a specific amount of homes, and we know that in terms of the space complexity, we know that we're going to be just processing uh, six, uh, 1, 2, 3, 4, 5, 6 cells. We don't want to process these ones. So it's basically a constant space, because you have a constant amount of things, and the possibilities you can go through is like they are limited. So basically 6k arrays per 2. uh, Basic different possibility, it could be any number, but I mean, uh, because that there are limited options we can go through, as we know that they're gonna stay total number of total number of cells are gonna be constant. So space complexity is constant, and whatever conditions of them are there, the time complexity also is O of 1. Yep, those were the things I wanted to cover. Thanks for watching.